All right, so this one I'm going to do solving distance, rate, and time problems. Again, using rational equations. The table is here to just help organize the information. One thing also to keep in mind is that we will need that distance, right? Distance is equal to rate times time. Or if you divide by r and divide by r, then you could also say that time is equal to distance divided by your rate. It says a cyclist traveled 9 kilometers per hour. So again, let's start making some notes over here. We've got distance. We're going to have a rate. We're going to have a time. And then there's also two different things happening here. We've got a cyclist and we've got a skater. And they're already giving us some information. The cyclist traveled at 9 kilometers per hour faster than the skater. In the time it took, the cyclist to travel 45 kilometers. The skater went 30 kilometers. Find the speed of the skater. So you always want to focus on, like, what is their big question? Find the speed of the skater. And so what we'll do is we'll let x be the speed of the skater. And so that's what we don't know, but it does have a place to go. Here is your skater rate. Okay, there's the rate, and so the skater is x. Okay, that's the speed of the skater, the rate of the skater. And now let's go back to some things that they said. One of the very first things that was said is that the cyclist traveled 9 kilometers per hour faster than the skater. And so the cyclist is x plus 9. So whatever the rate is of the skater, they are that much faster than the skater. Now the time, we'll come back to that, but it says that in the time, which that does mean that they have the same amount of time that they were both doing this activity, their activities. It took the cyclists, they were able to travel a distance of 45 kilometers. And I'll put little things over here, kilometers. This was kilometers per hour. And in that same amount of time, the skater went 30 kilometers. And so now we just need to fill up our time. And remember, time is the same thing as distance divided by the rate. And so the distance for the cyclist was 45, and the rate was x plus 9. So that's what the way we fill in the time, the distance over the rate. Same thing for the skater, the distance over the rate. And because they say that in the time, they are saying that the times are the same. So this time and this time are the same times. And so the way that we get our equation is we take the time for the cyclist and we take the time for the skater and we set them equal to each other. And the one ways that we could get this, and I do have the answer down here, this is what we're going to be heading towards, should be 18 kilometers per hour, is we could do cross multiplication. Right? The 45 times the x and the x plus 9 times the 30. And then do distribution. Okay, now we're just working to try to get the x by itself. Or right now we're trying to get the x's together. So we'll do minus 30x, minus 30x. So we got 15x is equal to 270. Divide by our 15, divide by our 15. Again, does 270 divide 15, so there's 18. And so that's where our answer came from. X is equal to 18. But again, they were asking for the speed of the skater, and that's it. The skater is going at 18 kilometers per hour. Let me do another one. It says Goran swam 8 kilometers against the current in the same amount of time it took him to swim 16 kilometers with the current. The rate of the current was 1 kilometer per hour. How fast would Goran swim if there were no current. And so again, focus on the question first of all. How fast would Goran swim if there were, so they're asking for his speed, right? How fast was he? So we're going to let x be Goran's speed. Okay, how fast would Goran swim if there was no current? So just him by himself, no current. So again, we're going to have distance, we're going to have rate, and we're going to have time. Now, it's Goran either way, but the thing that's different about the event is one of them is against the current, and the other one is with the current. Now, do they tell us how fast the current is going? Yes, they say the rate of the current was 1 kilometer per hour. So kilometer per hour. And so we don't know Goran's speed, but we do know that when he's swimming with the current, this is good. It's like he's getting an extra boost. So x plus 1, the current is helping him move along. Now, when he's going against the current, it's Goran's speed, but it's going to be a minus here because he's having to go against that resistance, fighting against the current. Now, it also tells us that in the same amount of time that it took him to swim, it says that he was able to do 8 kilometers when going against the current. So here is 8 kilometers. And then the same amount of time with the current, again, he was able to go faster. He was able to, and so he was able to travel 16 kilometers. And so this is another one of those things where we know that time is the same thing as distance over the rate. Again, kind of going back to our last example, time is distance over rate. And so we will take 8 over x minus 1 and 16 over x plus 1. And because the times are the same, this time is the same as this time, we can set up a equation where the against is the same thing as the time. And then now we can do, again, the cross multiply. So we'll have 8 times the x plus 1 and the 16 times the x minus 1. Again, this should lead to 3 kilometers per hour. Let's do our distribution. Let's get our terms together. Minus 8x, minus 8x. Let's add our 16 while we're at it. So we get 24 is equal to 8x, and then divide up our 8. Divide our 8, and we get x is equal to 3. And so remember that we were looking for Goran's speed, regardless of whether the current is helping him or not. That's how fast Goran is traveling. But again, there's 2 distance problems, distance, rate, and time problems. I hope